Welcome to Knowledge Share channel. In this video, we will be discussing about the SR flip-flop, and in detail, we will be discussing about the positive edge triggered SR flip-flop. Hope you're all having the understanding of the difference between the flip-flop and the latch. Okay, so if you want any detailed explanation, please refer to books. So here in this video, I will be just explaining how this SR flip-flop will be working and what are the circuits associated with it and what is its truth table. So this is what we are going to discuss. And you all know that any flip-flop can be achievable by means of NAND gates and NOR gates. So here the SR flip-flop, the first figure shows the SR flip-flop with NAND gates. The second figure shows the SR flip-flop with the NOR gates. So here you can see that the expansion of SR is nothing but set reset. So this is nothing but that's why it's in short it is called as SR flip-flop. In some books it would have been given as RS flip-flop. So this is the logic symbol. So here the clock pulse will be given, S and R is there and Q and Q bar is there. Okay. So it is having three different inputs. One is S, the other one is R, and clock pulse is given, and Q and Q bar are the outputs of the SR flip-flop. So here you know that flip-flops are used as memory elements. Okay, so it's having large applications. So from the truth table you can understand that if S is for example, if the clock pulse is high, and if S is 0 and if R is 0, if both are 0, then you can see that the Q1 and Qn plus 1 will be the same. Okay, there will be no change. Okay, and similarly what do you mean by reset? So for example, if R is 1 and S is 0, you can see that the Qn plus 1 is the next state, that is Qn is the previous state, so it will be 0. So since it is reset, so since its reset is 1, so reset that is Qn plus 1 will be that is 0. Okay. Similarly, if S is 1 and R is 0, you can see that Qn plus 1 will be 1 irrespective of the state, that is Q1, so reset will be equal to 1. So if all the states are 1, then it is an indeterminate state, so it is not advisable to go with that state. Okay. So similarly, if 0, for example, if the clock pulse is 0 also, then there will be no change. Okay. So here the input is given, that is the clock pulse, and the edge detect circuit is nothing but a differentiator is there. The circuit output responds to positive edges of the clock pulse alone. Okay. So here this is the explanation for this. So 4 different cases are there. So for case 1, you can see that if S equal to R equal to 0 and the clock pulse is applied, the output do not change, that is Qn plus 1 will be Qn, that is Qn plus 1 is nothing but the next state and Qn is nothing but the previous state. So this is indicated in the first row of the truth table. And in case of case 2, that is S equal to 0 and R equal to 1 and the clock pulse is applied, then you can see that since S equal to 0, that is set equal to 0, so Qn plus 1 will be equal to 0 irrespective of the Qn value. So this is indicated in the second row of the truth table. So this is indicated in the second row of the truth table. And third case, that is S equal to 1 and R equal to 0 and the clock pulse is applied, so Qn plus 1 equal to 1, that is the next state will be equal. This is indicated in the third row of the truth table. If S equal to R equal to 1, so as I have already told, there is nothing but an indeterminate state. So when the flip-flop will be undefined, so this is called as indeterminate state. So hope you are all clear with the working of SR flip-flop, and this is the logic symbol, and this is the truth table, and this is the SR flip-flop with the NOR gate, and this is the SR flip-flop with the NAND gate. So thank you very much for sharing and being with me in this video, and if you really like this video, please give a thumbs up. As well, if you have any doubts, please comment in this below comment section. And if you really want to found this video will be helpful to someone, please share it. And as well, if you like the videos which I post in this channel, please subscribe to my channel. Thank you.